You want to estimate the mean SAT score for a population of students with a 90% confidence interval. Assume that the population standard deviation is lowercase sigma, which is equal to 120. If you want the margin of error to be approximately 10, what is the desired minimal sample size? Well, the key pieces of information that we have here are that we are looking for a 90% confidence interval. That means that our confidence level is 90%. We're also told that the standard deviation is lowercase sigma, which is equal to 120. And we're also told that the margin of error is about 10. So we know that the margin of error is equal to 10, and we have to determine the desired sample size. So n is equal to what we're looking for in this problem. Now, since we don't actually know the mean within our current sample, we're going to go back to and use the margin of error formula for population proportions, and that is that the margin of error must be greater than or equal to the critical value z star times lowercase sigma, or our standard deviation, divided by the square root of n. So we know our margin of error is 10, so let's substitute that in. 10 must be greater than or equal to our critical value z star. Now, for a 90% confidence interval, that z star value is 1 and 645 thousandths. And we know that lowercase sigma is 120 divided by the square root of n. Now, if we cross multiply and divide here, we'll get that the square root of n is by itself on the left, and that's greater than or equal to 1 and 645 thousandths divided by 10 times 120. And if we substitute this into a calculator and evaluate it, we get that the square root of n is greater than or equal to 19 and 74 hundredths. And then in order to get n by itself, we need to square both sides. So if we take our answer and we square it and evaluate, we will get that our n value must be greater than or equal to 389 and about 67 hundredths. And then because this value is more than 1/2, the best value for n would be at least 390 scores. So that means at least, because it's greater than or equal to, and all of these are at least. And then the answer is 390 scores, or answer choice B.